Hello, I want to give you appreciation for the idea that energy comes in many forms, and we'll start with this device right here. This is called Maxwell's wheel, and it's a heavy metal wheel, and it's been lifted up above the height of the desk. So we say that it has the potential to be set into motion. All I really have to do is remove this piece of tape that's holding it in place and get it started. And as it falls lower and lower toward the desktop, it's going to lose its gravitational potential energy. But at the same time, it's going to be gaining energy of motion. It's going to gain kinetic energy. And it turns out the amount of kinetic energy gained exactly matches the amount of potential energy lost. The total amount of energy in the system remains constant. In fact, in this case, mechanical energy almost remains constant. Anyway, let me show you what I'm talking about. So once I release it, it converts gravitational potential energy into rotational kinetic energy as well as translational kinetic energy. And now it's losing the kinetic energy as it rises higher, and it turns out it comes back very nearly to the same height it was released from. Why doesn't it come all the way back? There were some non-conservative forces at play, which means that mechanical energy might have been lost, but total energy wasn't. Any mechanical energy loss was just converted into a wasted form of energy that really is nothing more than thermal energy. Think of it like heat was transferred into the classroom, largely because of air resistance in that case. Elastic potential energy, how about this? All right, see if I can shoot it right at you. Okay, so as I pull this back, I'm doing work, and work is really nothing more than the transformation of energy. Let's see, what did I eat for breakfast? Oh, I had some toast and jam for breakfast and a little bit of coffee. And that stored chemical potential energy in my body. So when I engage my muscles and I apply a force through a distance, we say I do work. Really what happened was the energy that's available now in my body has gone down, and it's appeared as the elastic potential energy stored in this bowstring. And if I let it go, now the energy is no longer in the bowstring, but it became the kinetic energy of that arrow. What else do we have? Oh, similar to that is this toy dart gun, right? So if I compress it, now energy is stored in a spring inside of this, and if I release the trigger, it's converted to kinetic energy. This one's pretty neat, this flashlight. There's no battery in it. Right? How well can you see this one? There's a coil of wire and there's a magnet. And if I shake it, that magnet moves back and forth through the coil of wire. And thanks to something known as Faraday's law of electromagnetic induction, just a fancy way of saying you can convert energy of motion into electrical energy. I generated electricity that was stored in a, I don't know if it's a capacitor or rechargeable battery in here, but anyway, now when I turn it on, can you see on here the light bulbs look? Well, in person it would be more impressive, so I have another version of this same demonstration here. So instead of making it the electric current that I generate power a light bulb, I just have an ammeter, something that can measure electrical current. And then this is just a coil of wire, and there's a magnet. And so if I move the magnet through the coil of wire, you can see the needle on my ammeter move. Oh, we're a little blurry here, aren't we? Right. As long as there's energy of motion, that energy of motion can be converted into electrical energy. What do we have here? Oh, yeah. Twist the propeller, and more elastic potential energy is stored in this rubber band. The more I twist it, the more the chemical potential energy in my body is reduced as the elastic potential energy in the rubber band is increased. If I let it go now, I can make it fly and we can give the plane kinetic energy. Or maybe I could let it go this way and let it fly. And then instead of moving faster and faster, it'll rise higher and higher, and will convert the elastic potential energy into gravitational potential energy. I don't want to break it, so I'm not going to let it go right now. So those are a lot of the forms of energy we'll be talking about in this unit of study. Elastic potential energy, gravitational potential energy, kinetic energy, thermal energy. What we're going to get to ultimately is the idea that no matter how many times energy is converted from one form to another, the total amount of energy in the universe or in any closed and isolated system remains constant.